Hari Om. Okay, so now next let us come to the topic system of linear equations. So you have already seen something like this in earlier classes. You know how to solve a linear equation which has two variables and there are two equations. You can find x and y by using elimination method or cross multiplication method or direct substitution method also. So if we have more number of variables, to solve them we will require more number of equations. So by using those three methods that you have learned earlier, solving a linear equation will be difficult. That's why we have to use the matrix method or determinant method. So what to do in this case? Suppose we have three variables and equations like this. So a1x plus b1y plus c1z equals to d1, out of which x, y, z are variables and others are constants. Similarly, a2x plus b2y plus c2z is equal to d2, a3x plus b3y plus c3z is equal to d3. So suppose we have this system of equations solving which we are going to get x, y and z. In matrix method, we represent them as a matrix something like this. So a matrix into another matrix will give us d1, d2, d3. So this matrix is x, y, z, and this is the coefficient matrix. This matrix is called as coefficient matrix. And how do we write it? Write the coefficient. So a1, b1, c1, a2, b2, c2, a3, b3, c3. Alright. Now, if you can write these equations in this form, now what will be x, y, z? So x, y, z will be a1, b1, c1, a2, b2, c2, a3, b3, c3, inverse d1, d2, d3. So this matrix is in LHS. If it goes to RHS, we will have to get an inverse. So the value of x, y, z will be, you have to calculate the inverse, multiply with d1, d2, d3 to get the value of x, y, z. So before that, there is a rule called Cramer's rule. He had devised a easier way to solve these equations. Let's see how to do that. Now, the linear equations, system of linear equations are of two types. If all these constants are 0, if d1, d2 and d3 are 0, such a system is called as homogeneous system of linear equations. Alright, and if d1, d2 and d3 are not 0, then they are called as non-homogeneous. Alright, so now let's first see non-homogeneous linear equations. So non-homogeneous means d1 and d2 and d3 are not equals to 0. So d1, d2, d3 not equals to 0. So for that case, what Cramer did was, he made some determinants. He denoted D, capital D, as the determinant of the coefficients a1, b1, c1, a2, b2, c2, a3, b3, c3. This, if you find the value of this determinant, its value is capital D. Now, he had three other determinants like this, d1, d2 and d3. In d1, what he did, he replaced the first column with these constants. So d1, d2, d3, b1, b2, b3, c1, c2, c3. This is the first determinant, and d2 is, he replaced the second column with d1, d2, d3. So a1, a2, A3, D1, D2, D3, C1, C2, C3. Now in D3, to get the capital D3, he replaced the third column with D1, D2, D3. So this is A1, A2, A3, B1, B2, B3, D1, D2, D3. Alright, so solving these, now once you get the value of D, D1, D2 and D3, you can find X, Y and Z. X is D1 by D, Y is D2 by D and Z is D3 by D. Alright, so this is what Cramer formulated a way. Now from here we can get some different cases. Try to remind yourself in the case of two straight lines. So either the straight lines may intersect at a point, or they may be parallel, or they might be coincident. So means a system of linear equations might have a single unique solution, or it might have infinitely many solutions, or it might have no solution. So if a system of linear equation has no solutions, it is called as inconsistent system of linear equations. So inconsistent means no solution. If it has a solution, if it has either one solution or many solutions, it is called as consistent. It is called as consistent. Now from this formula, if D is not equal to 0, if the denominator of all these fractions is not equal to 0, then you will get some value of X, Y and Z. So you will get some solution. So that will be a unique solution. And the system will be consistent if D is not equal to 0. Now, if D is equal to 0, if the denominator is 0, you won't be getting the values of X, Y, Z, because that will become not defined. And if along with this D1, D2, D3 all are 0, if all the 4 D's are 0, then we will have infinitely many solutions. But this is not always guaranteed. We might have infinitely many solutions, we may also not have. We will see a question related to this so that it will be much more clearer. But if D is equal to 0 and any one or more of D1, D2 and D3 is not equal to 0, then we don't have any solution. So no solution. So if D is not equal to 0, then we have a unique solution. But if D is equal to 0 and any one of D1, D2, D3 or more than that is not equal to 0, then no solution. If all the 4 are 0, we cannot say. So let's replace it. Cannot be predicted. Alright. So this is what Cramer has suggested, and this is what is Cramer's rule. So while discussing important questions in determinants, we will do some questions of Cramer's rule so that it will be much more clearer. But now we have considered this to be non-homogeneous. If the system is homogeneous, homogeneous means all the constants D1, D2 and D3 are 0. So this is 0, 0, 0. You can easily see that if we take x equals to 0, y equals to 0 and z equals to 0, all the equations are satisfied. So such a solution is called as trivial solution. Such a solution is called as trivial solution. Alright. Now here the value of D is A1, B1, C1, A2, B2, C2, A3, B3, C3. and D1 is, remind yourself of the last case. In D1 what we did, we replaced the first column with 0 0 0 with these constants. So here the constants are 0 0 0. So B1, B2, B3, C1, C2, C3. As you know, if one row or one column is 0, the value of the determinant will become 0. Similarly, D2 will also be 0 and D3 will also be 0. Alright, so here two cases arise. If D is not equal to 0, so X is 0 by D. D1 by D. D1 is 0, so 0 by D, which is equal to 0. Y is 0 by D, which is equal to 0. D2 by D. So this is D2 by D. This is D1 by D. And Z is also 0 by D, which is 0, is equal to D3 by D. So X, Y and Z are 0. And there is only one solution, and this solution is trivial solution. This happens if D is not equal to 0. But if D is equal to 0, so D1, D2 and D3 are also 0 beforehand. Now all the four are 0, so the system has infinitely many solutions. Alright, so more than this, we will solve questions to be much more clear. Okay, so let's stop here today. Thank you.